Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to see an application of transform and conquer algorithm design strategy. That application is Gaussian elimination. Now here we are going to see what is meant by this Gaussian elimination, for which purpose that we use this Gaussian elimination method. And we are going to solve one problem using one instance. We are going to solve one instance using this Gaussian elimination method, right? So coming to Gaussian elimination, this Gaussian elimination method uses transform and conquer approach to solve a set of equations. So here you are given a set of equations. For solving that set of equations, this Gaussian elimination method uses transform and conquer method. So additionally, it can be used to decompose matrices also. So matrix decomposition is useful to find inverse of a matrix and matrix determinant. Right. So Gaussian elimination names after Gauss uses transform and conquer approach to transform this set of equations with n unknowns. Right. So here it is named after a scientist, Gauss. Right. So it uses the transform and conquer approach to transform a set of equations with n unknown values. Now here Gaussian elimination method aims to transform a system of linear equations into an upper triangular matrix in order to solve the unknowns and derive the solution. So here this transform and conquer approach, this Gaussian elimination method transforms a linear equations into an upper triangular matrix. So here you are given a set of linear equations. That set of linear equations are transformed into an upper triangular matrix. And this upper triangular matrix is used to solve for unknown values and to derive the solution. So here a pivot column is used to reduce the rows before it. Then after the transformation, back substitution is applied. So here we need to use a pivot column for reducing the rows before it, and then after the transformation, back substitution is applied. Right. So let us say Gaussian elimination is a method for solving a matrix equations of the form Ax is equal to B. Now here A is a matrix and B is a matrix and X is a variable. Right. Now here to perform this Gaussian elimination, we need to follow a step-by-step procedure. Here the steps are explained. Let us see. To perform Gaussian elimination, starting with the system of equations, first we need to represent the system of equations in the form of a matrix. Now let us see. Here this represents the matrix for the given system of equations. That is, this is the first equation, and this is the second equation, and this is the third equation, and so on. Right. So like that, we need to represent in the form of a matrix. So after representing in the form of a matrix, we need to compose the augmented matrix equation. Right. Augmented matrix equation means we need to consider this constant part into this side. That is, this is the augmentation of this constant part into the coefficients. So here all these are the coefficients and this is the constant values. These constant values are augmented into this matrix. Right. Now after that, the column vector in the variables X is carried along for labeling the matrix rows. Now we need to perform elementary row operations as well as and column operations. So here we need to perform elementary row operations to put the augmented matrix into the upper triangular matrix. So here, whatever the augmented matrix that I have, now here in this matrix, I need to prepare an upper triangular matrix. So what is an upper triangular matrix? Suppose, for example, here I have a matrix like this. Here I have a 3 by 3 matrix like this is present. Now, what is an upper triangular matrix means? This matrix should contain the values on the upper triangle of the matrix. In these places, the values should become 0. In these places, the value should become 0. Then this matrix is to be called as upper triangular matrix. That is how we are saying this as upper triangular matrix means. Let us see. So here I have the elements in my matrix. Here I have, these are the elements which are present in my matrix. What is the diagonal of this matrix? This is the diagonal of this matrix. Right. Now, what are the elements which are present in the upper matrix? 2, 3, 7. What are the elements which are present in the lower matrix? 7, 5, 6. Now, the matrix should contain elements in the upper triangle to the diagonal, and the matrix should contain zeros in the positions of, in the place of elements below to the diagonal, lower part of the diagonal. So it is to be called as upper triangular matrix. Right. Now, if I need to convert the matrix what we have here as an upper triangular matrix, so by following some procedure. So here I will explain the procedure when we are solving the equations. Right. When we are taken an instance at that place, I will explain clearly. Right. Now here we are making, this is the diagonal of my matrix. This is the diagonal of my matrix. This matrix should be formed as a upper triangular form. So here only the element should be present. Here all the elements should become 0. In that form, I need to change my matrix. Right. So after changing, I need to use this type of equation to solve that problem, that particular problem for the unknown values. Whatever the unknown values are there, for solving those unknown values, I need to use this equation. So here you can understand all these 4 steps by seeing an instance. Now let us see the instance, how we are going to solve. Let us take, here we are given 3 equations. So the first equation is x minus y plus z is equal to 4. Second equation is x minus 4y plus 2z is equal to 8. Third equation is x plus 2y plus 8z is equal to 12. Now, how to convert this into matrix form? I need to take the coefficients of all these 3. Right. How I am going to represent? What is the x coefficient? There is nothing value. So that's why I need to take it as 1. What is the y coefficient? Here also there is nothing. I need to take, since there is a minus symbol, I need to take -1 is the coefficient of y. And here for z also there is no any coefficient. I need to take it as 1. Now for x, again, I have only coefficient 1. For y, I have the coefficient -4. For z, I have the coefficient 2. For x, again 1. For y, 2, I have the coefficient. And for z, I have 8. So these are the coefficients. And what the values that I have, what the unknown values that I have, x, y, z are the unknown values that I have. And what are the constants are given? 4, 8, 12. These are the constants given. Right. So this is the matrix representation. So which is in the form of AX is equal to B. So here this is A and this is X and this is B. Right. It is in the form of this equation. Now this is the matrix representation of given 3 equations. So after that I need to find the augmented representation. So how I am going to augment this matrix? Just I am going to move these elements to here. Right. Now I represented here. Let us see. 1 minus 1, 1, 1 minus 4, 2, 1, 2, 8, 4, 8, 12. This is the augmented representation for my matrix. So after that, what I need to do is, I need to make these elements as zeros to make it as an upper triangular matrix. That is the third step. That is, this is the diagonal. The elements which are present here, I need to make as zeros. Now, how I can make them as zeros? By using, so when I am going to make the elements, the element which is present in row 2, this is row 1, this is row 2, and this is row 3. This is row 1, row 2, row 3. How I can make the element which is present in row 2 is by using the elements which are present in row 1. So how I can make the elements which are present in row 3 as zeros means by using the elements of either row 2 or row 1. Right. Now I can use for making the elements of row 2 as 0. So this element I need to make as 0. For making it as 0, I need to use the elements of row 1. Here for I need to make these elements as 0. I can use either row 1 elements or row 2 elements. Right. Now here let us see. What I am doing is I am using, first I am going to implement the model on row 2. I want to make this element as 0. So for that, how I can use row 1 elements? Just simply by subtracting the row 1 element from row 2, I can get 0 here. Right. So that's why what I am doing is row 2 is equal to row 2 minus row 1 that I am doing. Row 2 minus row 1 that I am doing. So here what I will get the values, let us see. Row 2 is equal to what I am doing? Row 2 minus row 1 values. So first let us take this value. Let us take this value. So here the value is equal to, what is the value present in row 2? 1 minus, what is the corresponding value present in row 1? 1, which becomes 0. So here I written 0. Here this value, so this is equal to minus 4 minus 1. So what is the corresponding value in row 1? That is minus 1. Minus 4 minus 1. That is minus 4 plus 1. So which becomes minus 4 plus 1, which becomes minus 3. So this value becomes minus 3. Again, this value minus this value. So which gives 1. Right. I need to implement the same formula for constants as well. 8 minus 4, which I will get 4. Right. So I made this value as 0 till. Right. So first I implemented this formula and I made this value as 0. Next I need to make these two values as also 0. So first I am going to do this value as 0. How I can make this value as 0? Same formula that I can apply. Row 3 minus row 1. Right. So 1 minus 1, 0. 2 minus 1, 2 plus 1. That becomes 3. 8 minus 1, which becomes 7. 12 minus 4, which becomes 8. So now in this case, this also becomes 3. Next, I need to do this element as 0. Then I can solve the problem. Right. Now let us see how this can be transformed into 0. Now here you can see. Now here I got, after transforming these two, I got this matrix in the earlier step. Now how to transform this one? So here what I am doing is row 3 is equal to row 2 plus row 3. Here I am using row 2 elements. Now I am using row 2 elements. Right. Now just this is 3 and this is minus 3. Just by adding these two, I can get this value. Right. Now the same thing I am doing. Now R3 is equal to R2 plus R3. That is 0 plus 0, which becomes 0 only. So here R3 plus R2. 3 plus minus 3, which becomes 0 here. Now 7 plus 1, which becomes 8. 4 plus 8, which becomes 12. So finally, I get this matrix, this reduced matrix. So here I get this reduced matrix. Right. Now, from the reduced matrix, how I can write again the equations, how I can transform the given equations. The final equations are written as x plus minus y plus z is equal to 4. Here x term is not present, so that's why minus 3y plus z is equal to 4. Here x and y term both are not present, only z term is present, so 8z is equal to 1. Right, these three equations are written. Now we transform the given original equations into this form, simplified form. Right. Now I need to solve, I can solve this equation, I can get z value. Right. 8z is equal to 12 means z is equal to 12 by 8, which I will get its value as 1.5. Right. Now by using this z value and by substituting this z value here, I can calculate y value, and by substituting y and z values, I can calculate x value as well. Let us see. Now here z is equal to 1.5 minus 3y plus z is equal to 4. I know the second equation. In that I am going to substitute z value and I am going to find the value of y, which is minus 0.83. Now this y value and z value, what we got earlier, those two values are substituted in the first equation. Then we will get the x value as 1.67. So finally, the solution is 1.67 minus 0.83 and 1.5. So which is solved using Gaussian elimination method. So I hope that you all understood how to solve the equations using Gaussian elimination method. How this Gaussian elimination method uses transform and conquer. So it transformed the given equations into simplified versions. So this uses the transform method. And finally, we are getting the solutions by conquering the solutions of the subproblems. Here the first subproblem is Z value. Finding the Z value is the first subproblem. Now after finding Z value, I go for finding Y value and I go for finding X value, right? So I hope that you have understood how to solve this problem. Thank you for listening. Thank you.